delicious. They are
It
delicious.
is a graham cracker, right?
Yes, it pretty much is graham cracker. That's why Delta thinks it's
All right, here we go. Today we are talking about the chi-square test. Okay? Chi is a Greek letter. Okay? And it looks like an X. There's actually known as kind of like an italicized X there. So whenever you see that, that means chi-squared. You are performing this test. So today you guys are going to be able to determine whether or not the data sets are dependent on one another. This is the last section of statistics. Okay? This one is always tested on the IB exams. So it's very important that you guys know how to do this. We'll be spending today as well as Thursday on this test to make sure you guys are good to go.
When's your test?
Probably next Thursday.
Okay.
Probably. Okay? So it depends on how well you handle this as well as the other stuff. Okay? Now, this test is used to determine whether or not certain sets of data are independent, meaning whether or not two sets are dependent on one another, i.e. how tall you are and shoe size, or your gender and your favorite color t-shirt, or the number of hours you sleep and GPA, etc., etc. You would use this test to determine whether or not these two things would depend on each other, okay? So, there are 4 main steps to perform the chi-square test. And so, as we go through these 4 steps, we're going to basically apply it to an example. So, by the time we get through all the steps, or by the time we get through the example, we've gone through all the steps, okay? So, the example we're looking at, suppose you collect data on favorite color t-shirt for men and women. You may want to find out whether color and gender are independent or not, okay? So maybe, you know, it's true, statistics can prove that ladies like yellow and pink shirts and guys like black and blue shirts or something. You can actually determine statistically, mathematically, whether or not color and gender are dependent on each other. Okay? So, here we go. The first step is an easy step. You write the null and alternative hypotheses. Okay? Null can be used the symbol H sub 0. And alternative H sub 1. Okay? So if the question says write H sub 0, you need to recognize that that means write the null hypothesis. And then H sub 1, write the alternative hypothesis. Now H sub 0 states that the data sets are independent. And H sub 1 states that the data sets are not independent. So if you have to do this, these are 2 easy points to get, okay? Because all you literally have to say is whatever is independent of whatever, and then whatever is not independent of whatever. Like, it's just that simple, literally, okay? So, for our example, right, what are we talking about here?
Color and gender. Color
and gender. Now, the order in which it's given to you, or that you're trying to determine which is independent of which, is how you should state it. So here where it says we're going to determine whether color and gender are independent or not, then the null hypothesis for this particular example is going to be color of t-shirt is independent of gender. Okay? Because color, we're comparing color to gender. Okay? So for our example, t-shirt is independent, and you do have to write it out, of gender. And then H sub 1 would be what? The exact same thing, but with the word not. So these are 2 easy points you can get here, okay? Just make sure that you have the order right. And if you don't, then that is going to alter steps 2, 3, and 4. Make sure it is going to alter steps 2, 3, and 4. All right, so these are your 2 statements, easy points. Now step 2 is you have to actually calculate the chi-square test statistic. Now, when you go through this test, it is a few steps, okay? I say it's 4 steps, but there's really like a lot of things you have to do within each step, and they're not in your reference booklet, Okay, so you're gonna have to remember every step. Okay, so the first thing that you have to do is you may need to put your data into a contingency table, which shows the frequencies of your two variables. Okay, the elements in the table are the observed data, and the elements should be frequencies, not percentages. Okay, so sometimes, and oftentimes actually, your contingency table will be given to you. Okay, so if it's like an IB exam question, that table will be given to you. However, if you decide to do a statistics-based IA, you have to create your own. I mean, it's very simple. Basically, you're just making a frequency table. That's all you're doing. Okay, that's all you're doing. Now, for our example, here is the contingency table. Okay, so we have males and females, and then these are the 4 color shirts that they decided to select on. So there were 48 males that said they liked black shirts. There were 46 females that liked white shirts, et cetera, et cetera. This person interviewed 150 men, 150 women for a total of 300 people. And so there were 83 who liked black, total 58 that liked white, so on and so forth. Okay? So there you go. Make sure everybody can read the table. Now, if the total column is not there, say they give you the contingency table but not the total columns or row, make sure that you still fill it in, okay? Because you're going to need that later. Now, from the observed data, you can calculate the expected frequencies using the formula for the probability of independent events. Well, what is the formula for probability of independent events? It's basically the probability of one event happening times the probability of the other event happening, okay? So, you're given a contingency table. You need to create an expected value table, okay? So, in order to create that table, you need to figure out a few of these different values. The expected number of men who like black t-shirts. Now, you guys can see this pretty easily because the table's right there in front of you. I'm going to have to flip back and forth. But, how many men were there out of all the people that they interviewed?
150.
150. So that was 150 out of how many?
300.
Out of 300 people. Okay? Now, how many people in total liked black shirts?
83.
83. 83 out of how many people?
300.
Out of 300. You're going to multiply these two probabilities together. That's how you're going to get the expected value for men who like black shirts. You take the total number of men that you have and multiply by the total number of people who like the particular color, and that's going to give you your expected number of men who like black shirts. So what's 150 divided by 300 times 83 divided by 300? Everyone should be doing this.
0.138.
0.138?
Yeah.
I mean, it goes on, yeah?
Yeah.
Okay.
I got 13833.
All right, and it goes on. So this is not the expected number. I do apologize. This is the probability. So to find the actual expected number, you have to multiply by the total number of people that there are. So take that number and just do times 300. What do you get?
41.5.
Okay, buddy. 41.5.
41.5. So that's the expected number of men who like black t-shirts. Now, before anybody says anything, you're like, well, you can't have 0.5 per person. True, but you do not want to round for this expected value table. Do not do that. It's going to throw everything off. Okay? But why? Because basically the chi-square test it compares your observed data with your expected value data, and then it does this whole type of calculation to determine exactly whether or not we're going to accept or reject that the original hypothesis. So do not round. Okay? So that's how you go about finding your expected values. These values are going to go into a table. Let's figure out the number of men who like white shirts. So we take the probability that you pick a man, What's that fraction? Out of 300. And then you have to multiply by the probability that this person likes a white shirt. How many people like white shirts?
58.
58 out of how many? Bless you. 300. By multiplying these together, we'll figure out the probability of men who like white shirts. Once we figure out what that number is, we'll multiply it by 300 to figure out exactly how many men like white shirts. So go ahead and do this in your calculator.
My number seems too big. I'm gonna
Make sure you multiply by 300. 29.
No, it's not. That is not right.
Times 300. I
How
got
y'all doing?
29, yeah.
It should be 29.
Okay. Yeah, it's not to be
So
right.
just make sure that everyone's okay with this multiplying. Make sure. Okay? 150 divided by 300 times, what was it? 58? 58 divided by 300. Okay? This will give you the probability, but remember to find expected value. We talked about this before. You take the probability and multiply by however many are in your sample, and then you get 29.
That's what I
Okay? Now I want you to figure out the number of men who like blue shirts and the number of men who like red shirts, okay? I want you guys to do that now.
There we go.
Alright, so the number of men who like red t-shirts, you said did 150 divided by 300 times,
75 over 300.
and then took that answer and multiplied it by 300 to get 37.5. And lastly, for the number of men who like blue t-shirts, that is 150 divided by 300 times.
84 over 800.
You take that number and multiply by 300 and you get 42. Now, Vivian brought up a good point. She says, well, since there's an equal number of men that there are to women, can't we just take the total number and divide by 2? Yes, you can. But that's only because the values are equal. Okay, you have the total number of same number of men that you interview, the same number of women that you interview. If they were different, then this is the process you would have to go through to figure out what these what the expected values were. Okay? Does everyone understand that? All right. So we need to plug this information into our table. So we know that men in black, that was 41.5. White was 29. Red was, and blue was 42. We could do the exact same thing for the female, but the thing is, since we do have the same number of females that we have for men, the values in the female row are going to be the same. However, if these two totals were not the same, you would go through the process again, except using whatever the woman total was. Yes?
I think you should take the male number from the total number.
Or you could do that as well, because in an expected table of values, these two values should add up to be the total from the original
Hey,
frequency table.
I said something smart.
Okay?
Yeah.
These two numbers should add up to be the totals, and these totals come from the last table. Yes?
Couldn't you also just take the numbers that you got and multiply them by a ratio of men to women?
You can do that as well. Yes? Yes.
That was Amy.
The only reason why we can divide by 2 is because we interviewed the same amount of women and men. If they were different, then we wouldn't be able just to divide by 2. We would have to do a ratio like Brian said. Okay? But there are, as we can see, there's different ways to find the expected table. Okay? But they are based off of the fact that they're independent probabilities. Okay? Now, are there any questions? Alright, the expected values can never be less than 1. Okay, so if you work this out and you end up with a value that's less than 1, then something went wrong. Okay? Something went wrong. Now, to calculate the chi-squared value, you use the following formula. The sum of f naught minus f sub e squared all over f sub e. F sub 0, F sub O represents the observed frequencies, and then F sub E represents the expected frequencies. Okay? how you calculate the chi-square value. Okay. Now, yes, this is all still step 2. Okay. So, this is how you do it by hand. Are you going to be expected to do this by hand on your test? No, there is a calculated way to do it. However, if you're planning to do a statistics-based IA and you decide to perform a chi-square test, then you do need to do this. You do need to do this by hand.
Do you teach us how to type this out?
Huh?
Do we teach us how to type this out on the computers, or do you actually write it?
You actually want to type it into the computer like what you would do if you were writing it by hand.
I would teach us how to do that.
Find all these symbols and stuff.
Yes, it is. They are in Word. They are in Word. So, real quick. So, using your calculator, there are some steps. So this open space here is for you to write down the steps, okay?
Okay.
Are we ready?
Oh, we have to run.
Yes, I'm going to write down the steps, and I want you guys to write down the steps with me. So then that way you have them there, so that you can't say, oh, I forgot how to, So, when you turn on your calculator, you have to press,
Step 1, turn on.
Yeah, that's what I'm saying. So one.
turn it on, yes.
Alright.
You have to press the second button, and then you have to press this button. It says X to the -1. Above that button, you see there's a word called matrix, correct?
Yeah.
Okay, now when you do that, when you press that, you should get something that looks like this. If yours is blank, say there's not like a 2x4 or 1x1, whatever, that's fine. That's not important. What you do now is once you get to this screen, you go over to edit, okay? So you go over to edit. And the thing is you basically have to type in both tables. Your observed table and then your expected values table. Okay? So you want to go to edit, option 1, matrix A. Okay? So you'll click on enter. Now in matrix A, you want to type in your observed table. Okay? So in matrix A, you want to type in your observed table. And you only want the part, like the goods, okay? You want the part where it had the color of the t-shirts and the males. No totals. No totals, okay? Does everyone understand that?
Yeah.
All right. So if you look back at that table, just of the bulk, that's this part right here. This is a what by what table. Just that part. 2x4. It always is rows first, then columns. Rows go across, columns go up and down. Okay? So, it's a 2x4 table. So what you need to do is you have to let the calculator know, hey, I need a 2x4 table. So all you do is you change this to a 2, change that to a 4. You can press clear and it gets rid of it. So say I originally had up here that it was a 1x3. Okay? I needed to change, so I'm going to go over. I'm going to click 2. I'm going to press enter or the over button. I'm going to type in 4. But basically my matrix, as you see, turns into a 2x4 matrix, a 2x4 table. Okay? So then you type in your data from your observed table. Okay? That was 48. So you click 48, you click enter, and it goes across. What was the next value? We're going from the observed data. 12. What was next?
33.
33. Then
57.
57. And then
35.
35. And then
46.
and then
42.
and then
27.
Look, I made a mistake. All you have to do is just go back. It takes you to any spot in the matrix. Just use the arrows. So it's 42 and then 27. Okay? So, and I know you probably can't see your entire table. You might have the option that it moves it over. But that's okay. Just click the arrow buttons over and then it, goes to your table. Is everyone okay?
Yeah.
So you type in your data. Now we have to type in the data for our expected values. So we go back to second, we press X to the -1, and we go over to edit, but this time we're going to edit matrix B. Okay? And in matrix B, we're going to put in the expected table values. Those are the ones we found out, okay? So I'm going to do that. I'm going to press second, X to the -1. I go over to edit. I go down to option 2, and I'm going to edit my B matrix. Now, okay, the expected table's right here. Just like before, you only want the meat of the table. This is another what by what table? It's another 2x4 table. So another 2x4. So we're going to change the dimensions and then type in our data. Okay? So mine is a 1x1, so I'm going to do 2 over 4. I can see it turned into a 2x4.
Mine did a weird thing.
So the table that we found, we're just typing it all in. Okay? Is everyone good? Okay. So now, here we go. Here is how we calculate the chi-squared statistic using our calculator. What we do is we go to So what we do is we go to stat. So you press the stat button. You go over to test, because this is the chi-squared test, okay? And then we want to go down to where chi-squared test is. So we scroll down, and I don't know what number it was, so I'm scrolling for a reason. There it is. It's option C, okay? And you click enter. Now, I'm going to write that down. You press the stat button. You go over to test. And then you go down to option C, which is the chi-squared test. Make sure it's C, because as you see, D was another chi-squared, but it wasn't this chi-squared. Okay. Raise your hand if your calculator looks like mine. Wonderful. Okay. I'm going to talk to just the people whose calculator looks like mine.
Wait.
Like,
So
it doesn't have the color.
If it doesn't have color, it's fine. It's just because mine has the color option. Okay.
Oh,
All right. If it say it has everything but the color option, raise your hand. So no one's calculator looks different than mine. Mine is the color option.
Wait.
Okay. So did yours automatically put observed A and expected B?
Yeah.
That's why you want to make sure you type the observed in A and the expected in B. If you mix them up, you have to change them here. Okay? So just keep observed in A and expected in B. Don't worry about blue. Okay? Guys, I don't even know what blue's going to do. So
Change it to like yellow.
I want to hear you say that.
if I want to, yes, I can change it. Okay? There's red, there's black, there's
Magenta.
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 Orange.
Alright.
Magenta.
So what we're gonna do is we're gonna go down and calculate. Everyone's screen looks like this, yeah?
Yeah.
Okay, so then click calculate. Okay?
That was a good one.
And then here is your information. There is your chi-squared test statistic. It is 33.8.
8, sorry.
Okay?
Draw.
Question. So our chi-squared statistic is 33.8. Okay, so I'm gonna write that down. Chi-squared is about 33.8. Okay? Now the other numbers that are on here are important. They are important. The P, that is a P, is 2.22 times 10 to the -7. That's what that E means. E means standard scientific notation. And then DF stands for degrees of freedom. It stands for degrees of freedom. We could use all of these at one time. Okay? So, any questions on how we found the chi-square statistic?
Oh, those were the three
Yeah, those are the three blue
lines,
lines,
right? Those are the degrees of.
The three blue
Freedom.
lines. It all adds
You're
up.
5%.
Alright, so step 3. Step 3. We're not done yet. Not done. Step 3. You have to calculate the critical value. Okay? Now, to be honest, you'll only do step 3 in your IA. Okay? In examinations, it is given to you. Okay? Just like the level of significance is also given to you. Okay? These are two things that are used to help you determine whether or not color and gender are independent of each other. So we need to make a note of what the significance level is. It's given to you in examinations, but for IA, you have to decide which level to use. The most common levels are 1%, 5%, and 10%. Does it make a difference? Depending on your data, it could. But for your IAs, when you choose, whatever you decide, stick with it, don't change it. Okay? And then if you do, then you might have to restart everything over. Then you have to calculate the degrees of freedom. Now, we already know what the degrees of freedom are because we used our calculator. But a lot of the questions will probably be show that the degrees of freedom is whatever the number is. This is how you figure it out. You take your number of rows and minus 1. You take your number of columns and minus 1, and then you multiply them together. And we're talking about rows and columns of from your tables, okay? Both of your tables will always have the same dimensions. So the number of rows, the number of columns of either table, subtract 1 and multiply. Okay? Question on that? Alright. So, for examinations, the degrees of freedom will always be greater than 1. Always, always. However, if you would decide to do this for your IA and it is 1, then you'll be expected to use the Yates continuity correction to work out the chi-square value. Again, this is only for our A's. If you decide to do a statistics-based 1, you perform a chi-square test, and you get 1, then you and I will talk individually about the Yates continuity correlation. Okay? But again, examinations, degrees of freedom will always be greater than 1. So for our example, we already know from our calculator that degrees of freedom is 3. But let's show that is 3. How many rows did we have?
4, 2.
You had 2 rows. So we're going to subtract 1. How many columns did we have? 4. So we subtract 1. What's 2 minus 1? What's 4 minus 1?
3.
And 1 times 3 is 3. That's how you times 1 times 3. That's how you show the degrees of freedom. So even though the calculator gives it to us, we might have to be asked to show this. Okay? Everyone still with me? Okay. Now, the level of significance and the degrees of freedom can be used to find the critical value. In examinations, the critical value is given to you, okay? So for exams and for homework, you won't have to worry about finding the critical value. It'll be given to you. However, in IAs, you use the following table to figure it out, okay? Now, this table is a little bit, can be overwhelming, but let me just break it down for you real quick.
Oh, haven't we? No, we haven't.
Okay?
Yeah, Kyle, I thought it was the same thing too.
Chi-square distribution table, okay? It basically helps you figure out what your critical value is. Again, you only use this for your IAs, but I'm going over it now. In exams and on homework, they're given to you. This column represents your degrees of freedom. This here represents the decimal form of your significance level, okay? So if we have a degree of freedom of 3 and a 1% significant level, right? This would be our critical value. Does everybody see how I got that?
No.
You go along the row where the degree of freedom was 3. You go along the row, and then you go to the significance level of 1%, and you go down and you see where they intersect. And that would be your critical value.
No, I thought we did subtract.
Wait. How is that?
No, that was different.
How is that?
So, if If I go back here, it says, for example, at a 1% level, the critical value is 11 point, was it 345?
Yes.
Okay. Now at a 5% level, let's figure out the critical value. We still use our degrees of freedom, which is 3. And we're going to go to the 5% column, which is where?
7.8.
Right there. There's your 5% column. So you basically go to see where did they intersect. Here, and they go along that way. So 7.815. All right? And then at the 10% level, what's the 10% level? 6.251. So again, we go 3 degrees of freedom, we go across, see where they intersect, and it's right there, 6.251. And again, you only have to figure out your critical level, a critical value, if you're doing an IA. It's given to you otherwise. Yes?
How do you decide which of the different levels to use?
And to be honest, it's really dependent on you. Different critical values could give you a different result. It could actually determine whether or not it is, the two things are dependent on each other or not. It really depends on the data that you're given. Okay? But like I said, step 3 will be given to you on homeworks and exams. The last step, you have to compare the chi-squared calc statistic, the number that you got, against the critical value. If the chi-squared number is less than the critical value, then you do not reject the null hypothesis. You do not reject it. In other words, you accept it. Whatever you stated for your null hypothesis, then that is true. If the number that we came up with is less than the critical value. But if it's greater, then you reject it. Okay, in other words, whatever we stated as the null hypothesis at the very beginning, that is not true. Okay, you reject it. All right? Okay, so if we look at our example at a 5% level, the 5% significance level, our chi-squared test value, which was 33.8, is greater than 7.815. So therefore, we would reject the null hypothesis. Because that value is less than the critical value, we will reject the null hypothesis. This means that t-shirt color is independent of gender. So that basically means that the color of t-shirts you like has nothing to do with the fact that you're a male or a female. Which you probably had the idea that was already the case, because just because you are a particular gender doesn't mean that you like a particular color. So that's how you use the critical value and then the chi-square statistic to determine whether or not you accept or reject the null hypothesis. Now another way you can do this is you can also compare the p-value against the significance level. The p-value was the value that we found in the calculator, okay? That p-value. Because depending on what's given to you, they might give you the significance level and not the critical value, which means that in order to determine whether you accept or reject, you look at the p-value and then the significance level. So, if the p-value is less than the significance level, then you reject. So if it's less, you reject the null hypothesis. But if the p-value is more than the significance level, then you do not reject the null hypothesis. Okay? So in our example, our p-value was 2.22 10 to the negative 7. So that basically means that it was 0.000000222. Okay, because it was you basically had to move it back 7 decimal places. And that is less than our significance level of 5%. So at 5%, which is 0.05, that is less than, our p-value is less than that. So we are going to reject the null hypothesis. The same conclusion that we came up with before, but just using the p-value to get it instead. Right? So to recap, to perform the chi-square test, you write the null and alternative hypothesis. You calculate the chi-square calc statistic. Remember, use your graphing calculator for exams and homeworks, and you use the formula for projects. Remember, there's a separate video to show you how to do it by hand. You determine the p-value by using your graphing calculator, or you can use your critical value, which will be given to you sometimes. And then you compare the p-value against the significance value, or you can compare the chi-squared calc statistic against the critical value. All this comes from practice, so you gotta make sure that you